مرحبا شباب، كيفكم حبايب؟ إن شاء الله تمام. كيف الأمور؟ uh, Today we will talk about chapter 6, which is discrete random variables. Discrete means that it's not continuous. It's the opposite of continuous. When I say a uh, continuous data means that, for example, if I say the weight of students in a classroom, that's a continuous because I may have 70 kilograms weight, I may have 70.1, I may have 70.01, that's a continuous. For discrete means that if I'm looking for the numbers in an experiment of a die, even numbers. So that's a 2, 4, 6. 2, 4, 6 are even. That's a discrete because we don't have 2.1 on the dice. So that's called discrete random variables. Variables, something changes. And today we will learn about something called probability distribution table and probability distribution function. And we will talk with the examples I will give you. And let me just consider this example. 3 fair coins are tossed. Now, I'll take this example to the whiteboard. Now, if I have 3 coins, I have something called sample space. And you know what is the sample space, which is the all possible events. So I may have head, 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 tail. I may have head, tail, tail. I may have tail, tail, and tail. I may have tail, tail, head. We may have tail, head, head. We may have tail, head, tail, and head, tail, head. So we may have all of those. So we have 1, 2, 3, 4, 5, 6, 7, 8 possible events for the coin. Now, if my experiment is focusing on the number of heads in my experiment, so I may have 3 heads, I may have 2 heads, I may have 1 head, I may have no head, 1 head, 2 head, 1 head, 2 head. So my probability distribution table, which contains the variable x's, which is the head, and this is the probability of those events. Now, I may have 0 head. Now, in this lesson, in this chapter, they will always focus on a variable. They will not focus on both head and tails. They will focus and they will say it. We are focusing on head. So all we need to do is to construct our probability distribution table for heads only. So we may have 0 head, 1 head, 2 head, 3 head. Now, what's the probability to get a 0 head? 0 head, there is only 1 out of 8. 1 head, this is 1 and a 2 and a 3. So that's a 3 out of 8. 2 heads, that's a 1, that's a 2, that's a 3 heads. So that's a 3 over 8, and 3 heads, we have only 3 heads over here. Now, if you notice something, and this is very important in exams, the total probability is equal to 1. It's always like this. Now, this is useful. Let me point to that. In the exams, they may say A plus 2, مثلا 1 over 8, A 1 over 8, 2 over 8, and B, and there is a letter B, and there is 1 over 8 probability, for example. So this is an equation we can do from this, that is the sum of everything is equal to 1, and this could be one equation with two variables unknowns A and B, which you need to find another equations to solve it simultaneously. Now this is the idea behind this. Okay, now let me do this again. Who's joining me? بشار is joining me. أهلا بشار، كيف حالك؟
هلا أستاذ، كيفك
كيف
أنت؟
أمورك؟
أسعد بخير.
لا عادي، الله يسلمك. I was planning to make a record and anyone most welcome to join me. بالعكس، بدل ما أحكي لحالي I will have someone يسليني. Now, in this chapter, as I was saying, if we have an experiment of 3 coins, the sample space is as shown on the whiteboard. We may have 3 heads, 2 heads and 1 tail, and so on. You know this, right? صح? The sample space. So in probability in chapter 6, that's a discrete random variable. I was talking about discrete that is not continuous. Means if I have an experiment of head and tail, it's not head 0.5 and tail. We cannot have 0.1, 0.2. So that's a discrete. For continuous variables, continuous data, when we have the weight of students in classroom, it could be 70, 70.1, 70.15. That's a continuous. So we will focus in this chapter on discrete variables. We will focus on those questions. Inside this chapter, all those questions, they will tell you to focus on one event out of the events we have. For example, the 3 coins, we may have head or tail. In questions of chapter 6, they will tell you to focus on one event only. For example, this experiment is focusing on heads only. So we may have 0 head, we may have 1 head, we may have 2 heads, we may have 3 heads. Can we have more heads than this?
No.
No. So what's the probability that we may have 0 head? There is no head. Which event has no head?
T.
Exactly. That's a 1/8. And what's the probability to have 1 head?
One head, HTT or TTH.
تمام وهي. So
Or
that's a
TH.
3/8. And 2 heads.
HHT and
1, yes.
THH and
And
HTH.
exactly. That's a 3/8. And for 3 heads, we have only 1 value. So there is something useful in solving questions in this kind of questions. That is, the total of all probabilities should be equal to 1. That's called probability distribution table. That's a probability distribution table. This is number 1. They may ask you to write down the probability distribution table. Now we have something else here. They may ask us to write down the probability distribution function. And the probability distribution function, in fact, it describes the table. Now, the probability of x equals, now all probabilities, as you can see, they are either 1/8 or, hello, Bashar, معاي؟ Maybe you're facing, yes, you're facing problems with the mic. Okay, tamam. So the probabilities that we can see, I can see the chat. Okay, I don't mind, no problem. Just listen to me then. So the probability distribution function, either it will describe the probabilities that we have on the table. We have both, either 1/8 or 3/8. We don't have any more. So It could be 1 over 8 or 3 over 8. Now, in this case, I'll ask myself, what are the values of x, which makes 1 over 8 probability? The values of x, they were 0, so x equals 0, and 3. And I'll ask myself again, what are the values of x that the probability will be 3 over 8? So that's x either 1 or 2. So in this case, we have the probability distribution function. We wrote it in this way. Now in questions, you may find the function and they will ask you to write down the probability distribution table. So the otherwise, the other way around is the same one, 0 and 3. 0 and 3, we have 1 over 8 probability. When we have x equals 1 and 2, we have 3 over 8 probability. That's called a probability distribution function. Now let me come to this, number 3. The probability cumulative table. Probability cumulative, or cumulative probability table. Cumulative probability table. If you remember in chapter 2 and 3, we had cumulative frequency, and cumulative means that بالعربي تراكمي. That is the first frequency, then we will add the second frequency to the first, that's cumulative. And similarly, we may have the probability cumulative probability table when we have x and probability of x. I will rewrite down the table as it is. So if this is 0 and 1 and 2 and 3, and the probability is 1 over 8, 3 over 8, 3 over 8, and 1 over 8. Now the cumulative probability that we have, the first probability is 1 over 8, which is the same as this one. Then we start adding 1 over 8 plus 3 over 8, that's a 4 over 8. Then adding 3 over 8, that's a 7 over 8. And adding 1 over 8 over 8, that is a 1. And this one, in fact, this one is very important also in solving questions. In tests, in exams, it's very important, this one. لأنه بكونش معطيك إياها as a 1. بكون معطيك إياها a function, and you should equate it to 1, and you should find the variables. So we have two important things, which is the total probabilities in the probability distribution table should be 1, and the last cumulative data is equal to 1. Those two informations are there always in the exams. Now we have something number 4. Now number 4, it's called cumulative probability function. And in exams, they will not ask you. Now, let me point to another thing which is important in this table. Sometimes in the exam, they will erase the probability. They will not show it. They will not show the probability like this. Oh, undo. Okay. They will not show the probability, and they will ask you as a student to find them by showing the cumulative. Of course, the first one is as the first one, that's 1 over 8. Then what we used to do, we used to say 1 over 8 plus what gives you 4 over 8, that's a 3 over 8. 4 over 8 plus what equals 7 over 8, that's a 3 over 8. And that's a 1 over 8. This is the way how to find the otherwise. Now the cumulative probability function, we cannot convert from this table to that. It's never asked. They may give you the function and they will ask you to find this table. So this way is not there. مش زي the probability distribution table and probability distribution function. This question in two ways. They may give you the something connected with the distribution table to find the distribution function, or otherwise they may give you the function to find the table. But for cumulative table and cumulative function, they will ask you to find, they will give you the function, cumulative function, probability function, to find out the cumulative table, but the other way around is not there. I hope this is clear. Is that clear, Rashad? Just write down in the chat.
تمام.
Okay, tamam, ماشي.
مم.
Okay, now I will move to something else, which is called the mean, how to find the mean, how to find the variance for a probability distribution table. And let me just use that table, which I did over there. That's a probability of x, and the 0, 1, 2, 3, and 1 over 8, 3 over 8, 3 over 8, and 1 over 8. Now, the mean has a notation in this chapter, which is EX, and the variance has, that's a variance of X. That's another notation. Okay. المين اللي بنعرفه احنا عن المين, it's equal to the sum of f times x over the sum of f, as we know, the frequencies times the midpoint divided by sum of f. Now, is the scenarios different for the mean of probabilities? Of course not, and it shouldn't be. النوتيشن بيختلف, هذه x bar هذه ex ممكن, لكن the way of solving should be the same. Our rule used should be the same, لكن with different notations. I'll show you how. Now, we have f times x, which is the x and the frequency. The x is 0, and the frequency is 1. So 0 times 1 divided by the total of frequencies, which is 8 events. So all you need to do to find EX, or to find the rule for EX, in fact, as you know, we don't memorize rules. We understand how to make them. Sometimes during the exam, you need to make your own rules. So that's a 0 times 1 over 8. 0 times 1 over 8 plus 1 times 3 over 8, the data times the frequency divided by sum of frequencies, plus 2 times 3 over 8 plus 3 times 1 over 8. And what is this? What we are doing? We are multiplying the x's by their probability of x's, in fact. And we are taking the sum of those. So this rule is the rule for finding the mean for the discrete probability distribution table. Now let's think about variance. Variance, as we know, variance of x's is equal to the sum of fx squared divided by sum of f minus the mean square, as we know. Now let's analyze this rule, and let's use our notation for this chapter instead of chapter 2 notation. Now there is f times x squared, so means that we have to square the x's and multiply them by their frequencies divided by the sum of frequencies. Means what we are doing here is we are squaring the x's, multiplying them by their probability with the sum minus the mean square, minus the mean square. And how we can write this as a notation, as we are writing everything as a notation, we will say that we are finding the mean of x squares, in fact. Now this rule is similar to this rule, except there is a square. Means that is, what is the difference between those two rules, the mean and part of the variance? That's the mean of x squares minus the mean square. So the mean of x squares minus the mean square. So this is the variance, and this is the way how we can calculate the variance, and we can apply those two rules, the mean and the variance, in those data, this table. So we can find both of them, the mean and the variance. Any questions? تمام. Okay. تمام. Excellent. So we understood now the main concepts of how rule comes, of how we will use rules in solving problems. Let's come to another idea which we took before, in fact, in chapter 2 and 3, when we were talking about mean and standard deviation and variance. Now, the mean, which is the average for data. If, for example, if I suppose that those are all the data in my scatter plot, and the mean is a value which is supposed to be in the middle, that's an average between the data. For example, صف الشطار كلهم above 90s. المين تقريبا بيكون في النص بين الداتا 94 something شيء 95 إذا كانت يعني distributed equally من 90 ل 100 أو إنه المهم إنه المين is always the average between the data. Now, if I am adding, let's say the exam out of 10, and the principal, the administration told me that the exam should be out of 15. It means that I will add 5 marks to each data. Okay, لأنه في ناس جابوا مثلا 7 من 10, في ناس they got 8 out of 10, some people they got 2 out of 10. Okay, so I assume that I have to add 5 to each data, okay, or something. Now, if we are adding 5 to each data, all data will move from here to there. They will have the same distance between them, and the mean somewhere here. So do I recalculate adding for all data as 5 and then calculate the mean? In fact, I
لا
don't.
بس times
Yes,
5.
exactly. That just adding 5, because all data they moved from here to there, so the mean will move with them. So the mean is affected by plus and minus, similarly if we subtract, and affected by times and divide. So the mean is affected by 4 operation, mathematical operation. But for this variance, the variance of x's, now the variance is what? The variance, if I have
How close the data? Huh?
away from
Mm.
the mean, how close to the mean are they? Yani, we have a distance, we have a distance, we have a distance, we have a distance, we have, let's say, D1, D2, D3, D4, and so on. So the mean of all those distances is called variance. How far are the data away from the mean, the average of those distances? Now, in this way, if we are adding 5, just like this example, did the distance change? If we are adding 5, did the distance change? Of course,
لا.
لا, there is no change in the distance, there is change in position. Instead of x كانت 7 صارت 12. لكن
Mhm.
the same distance of the data from the mean are the same from here or there. So the variance is not affected by plus or minus. حتى even if you subtract or add, the distance is not changing between the mean and the data. So لكن it's not affected by plus minus, but it is affected by times and division Why is that? Because when you multiply, you will have enlargement. You will have enlargement. So the distance is changed. So the variance is affected by times and divide only, and it's affected by the square of the scale, the square of the number, because we have kind of enlargement, okay, by the square of the number that we are multiplying with. That number could be 2, that number could be half, okay? So we will get an area, but that's connected with similarity in geometry. Area 1 over area 2 is equal to side 1 over side 2 squared. That's why we'll square them. That's why we'll square the constant that we are multiplying with, okay? And division also the same. We will divide by, if we are dividing by half the marks, we'll divide by half a square also. Okay, is that clear? So let me come back to the example given here. And if I say, let's find the mean for those, I'll find the mean. So the mean is given by, that's a 0, 3 over 8 plus 6, 3 plus 6, that's a 9 plus 3, that's a 12 over 8. Means this is equal to divided by 4 by 4, 3 over 2, 1.5. Okay, now if the mean was given, calculate, they will say find 3x minus 4x, let's say 4x minus 1. So the mean was changed by this equation, that's linear equation, so 1.5. So I'll say 4 times 3 over 2 minus 1, that's a 6 minus 1, that's a 5. So this is the new mean that you will get. And similarly, if we have the variance, let's calculate the variance for this question. So the variance,
2 times 4 بس صح؟
let's calculate the old variance. That's e power, when you square data, that's a square, 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 means that's 3 plus 12, that's 15, plus 9, that's a 24 over 8, that's a 3. That's a 3. So minus the mean, minus the old mean, which is 1.5, so it's equal to 1.5. That's the variance. And when we say the variance is the variance of 4x minus 1, we need to calculate the new variance. The minus 1 is not affected by minus 1, it's affected by
Right,
4.
1.5 square.
Sorry? Sorry.
1.5.
Thank you. So that's a 3 over 2. When you square it, that's a 9 over 2. There is
3 over 4 تطلع.
3 over 4 when you square it.
لا 3 minus 2 يعني كلها آخر شيء الفاريانس
قصدك الجواب النهائي. That's a 3 over 4. Now, so when you do variance, new variance is 4x minus 1, we omit the minus 1, we don't have, and we multiply by 4 squared times 4, that's a 12. So in this case, the new variance is 12 was affected only by multiplying with the square of the 4. Okay, now for this kind of questions, and we will see some paper questions, just let me pause recording a little bit until we find some papers, some questions. Resume recording. Now, we find in the physics math tutoring, we have a lot of questions here, classified, you can check them. Now, the discrete random variable x has probability distribution given by this. Now, x, those that are the x's, minus 1, 0, 1, 2, 3. And the probability of those x's, the negative one, it's 1 over 5, and a, and a, and a. Now, find the value for it. Yes. Do you want to Can you have the chance to participate, Bashar? ولا find values of A? Now, as we have said, in the first slide of the video, we have shown that the total of all of those probabilities should be equal to 1. So when we add them up, 1 over 5 plus A plus 1 over 10 plus another A plus 1 over 5, this should be equal to 10 to 1. Now that's a 2 over 5, 2A, I will see, plus 2 over 5 plus 1 over 10. Let me multiply by 2. 1 over 10 equals 1. So that's a 4 plus 1, that's a 5 over 10. That's a half. So 2A equals plus that half equals 1. So 2A equals 1 minus half, that's a half, divided by 2, that's a 1 over 4. So this is a 1 over 4, and that is another 1 over 4. So this is the way how to find this variable, and it's very important. The total probability is equal to 1. This will solve a lot of problems for you. Now find the mean of x's. As you know, the mean of x's, it's the sum of x's times their probability. Oh, the sum of x's times their probability. So excuse me for a minute. Let me just okay. So let me continue what we were doing. So the mean of x's, the mean is we multiply all values of x. That's a negative 1 over 5 plus that's a 0, and that's 1 over 10, and that's 2 times 1, that's a half. And when I say 3 times 1 over 5, that's a 3 over 5. And in this way, the e of x, because I don't have space down there, that's negative 2. I multiply by 2 to make it 10, multiply by 5 to make it 10, multiply by 2 to make it 10. So that's a negative 2 plus 1, negative 1. Negative 1 plus 5, that's a 4 plus 6, that's a 10 over 10. That's equals to 1. That's a 1, sorry, 1, 2. That's a 2. 2 plus 1, that's a 3. 3 plus 5, 8. 8 plus 6, that's a 14. So I missed my calculation. That's a 14. Divided by 2, that's a 5. 7 over 5, that's a 1.4. We may use the fraction or decimal, whatever you want. So let me just go down a little bit to find out the questions, because I can't see the questions. Now find the variance of x, then find. Okay, so let's calculate. That's your ex. Let me write it down in this way. Now we need to calculate the variance. So let me erase all of this. The variance, that's 1 over 4. A equals 1 over 4. And the mean is equal to 1.4. So the variance of x is equal to, we square those x's, square them, multiply by their probability, square them, square. So negative 1 square is 1 times 5 plus, that's a 0 already, that's a 1 over 10, plus 2 squared is 4 times 1 over 4, that's a 1, plus 3 squared is 9 times, that's a 9 over 5. And similarly, times 2, and this is 10 over 10, because I don't have a calculator, and this is 80. So 2 plus 1 plus 10, 13 plus 18, that's 31. So the answer is 31 over 5. That's your first part of the variance minus the mean, which is 7 over 5. That's why I wrote it in two forms so we can easily subtract now. 31 minus 7, that's a 24. So 24 over 5, 24 over 5, that's equal 4.8 decimal. So this is the variance. Let me write it down. EX on عشان أقدر أمحي that's 1.47 over 5 or 1.4. The variance of x is equal to 24 over 5 equals to 4.8. So I'll erase all of this because we will go down right now, and I'll keep those data on the left hand side of the page. So I'll keep the variance and the mean for further calculations. Okay. So now we have this, and oh yes. Let's go downwards. Now the random variable y, find the new variance. New variance, of course, as you can see, these 6 will not be affecting, plus 6. It's not negative. The negative is for the 2, negative 2x. That's the gradient. That's the y-intercept. Mathematical analysis, not statistical. So we will multiply negative 2 squared times the old variance, that is 24 over 5, which is equal to, that's 4 times 24 over 5, that's equal to 69 over 5. As a decimal, you can write it down times 2 times 2, that's at 2, 18, 19, that's 19.2. Now calculate the probability of x is greater than or equal to I. Okay, this is your y. So as he is telling me, calculate the probability of x is greater than or equal to 6 minus 2x. Now that's an inequality. Let me solve it mathematically first, simplify it by using math. Now move this 3x greater than or equal to 6 divided by 2 greater than or equal to 2. So we are looking for, let me go up, we are looking for x greater, probability for x is greater than negative 2. Let this be in blue. So x greater than or equal to, that's a 1 over 4, if you remember. X greater than or equal to means it's the addition. So the probability of x greater than or equal to 2 is equal to 1 over 4 plus 1 over 5. And then we add them up. Okay, I think that the question is over. I think the question is over, yes. Now look at this. In this question, let me just erase everything. Now in this question, the probability function is given, and they want me to find a lot of things. Let me find out, first of all, the distribution table. That's your x, that's your px. And those are the values. We have 1, 2, 3, 1, 2, 3 x's. There is nothing else. And kx squared means that k times 1 squared, that's a k times 2 squared, that's a 4k, 3 times 3 squared times k, that's a 9k. As you know, the sum of those is equal to 1. Then you can find your k, which is equal to 1 over 4. Now, let me just go down to see what, find the probability of x greater than 2, ex, the variance, the new variance. Now I'm looking for questions which I told you before, which is the cumulative function. عشان نقدر نكتب, so we'll be able to write down the cumulative probability table. Now this question probability عادي, and this is the table. You can find the uh, so I'll be looking for that kind of questions. That's a probability distribution table, and you can find all of those from this. Okay, so this is the function. See? Oh, yes, this is the cumulative function. Question number 6. Now, question number 6. First of all, we need to find the table. Now, x's probability for x's, which is not given, and the function fx. Fx, not e. That's not an e. Okay, that's an fx. Now, x's we have 2, 3, 4, and the cumulative for each one of them. Substitute 2. That's a 2 plus k squared, 2 plus k squared over 25. And the other one, 3. 3 plus k squared over 25. And for the 4, 4 plus k squared over 25. Now, what is going to solve my question is the last value, which is supposed to be equals to 1. So 4 plus k square over 25 equals 1, cross multiply. So 4 plus k square equals 25. So 4 plus k equals 5. So the k equals 1. Oh, that's a 1. So the k equals 1 means that fx, I write it down over here, then I'll erase it from there. 2 plus 1, 3 square root 9 over 25, the first cumulative, which is the same as this one. 3 plus 1, 4 square root 16 over 25. I'll not do simplifying, that's a 1, which is 25 over 25. Now forget about this row. Now let's come to P. 9 over 25 is the same as it is. And then what plus 9 over 25 gives you 16 over 25? That's a 7 over 25. And what plus 16 over 25 gives you 1? That's a 25 over 25. That's a 9 over 25. That's it. We're done. Then you can find the mean and a lot of things. Okay. So please solve those documents. Try to solve the questions and send me whatever you feel that you could not do it. And this comes to the end of chapter 6. Thank you.